In this video, we complete step 35, the sort values method. So we're going to be sorting our data frame based on one or more columns with the sort values method. So this method is going to have two parameters. Number one is the column or columns that we are going to be sorting by. And the other one is whether we're going to be sorting ascending or descending. So by default, we're going to sort from lowest to highest. So ascending will be true. That's what ASC stands for, just ascending. And so those are the two parameters. So let's go over here and let's first do the case. Let's keep it simple just for a single column. So we're going to allow by, this column by, to be either a string or a list of column names. So we'll just so in the case that by is a string, it'll just tell us that we're going to be sorting a single column. So if by is a string, then we know that we're just sorting one. So let's go ahead and sort this by this particular column. So we get to get the underlying NumPy array. So that's it. So it's in the, we can use our underlying our data dictionary to get the underlying NumPy array. And then to sort by this, we're actually going to call argsort. We're going to pass it to the argsort function in NumPy, which returns the order. Gives us integers of the order. So we'll just say order equals like this. And then we will, let's go ahead and return. So we have self of order. So we're actually going to use the brackets that we've already implemented, with the getItem special method. So we're going to pass this order, which is just simply an array of, this is an array of integers of the correct order into here. Now, one small thing here is that order is going to be a NumPy array. So we're going to have to use the toList method, which is an array method, which just returns the values of an array as a list. And this is because we only implemented selection with rows with a list, so you cannot give it a NumPy array. So that's unfortunate, but that's what we did during the implementation. So yes, our data frame, which is self, we will select particular rows by passing in a list. This simply denotes that we will select all of the columns. So remember, you give it two items that are separated by a comma. So here we have rows, comma, columns. It's just going to, it will do simultaneous selection of rows and columns. But in this case, we're going to select all of the columns, which is why we just have a single colon, which is slice notation for saying slice all of them. So let's go ahead and look in the Jupyter Notebook here. And if we say we want to sort values by, say, the column weight, so it looks like goes from 40 all the way to 100. So basically the second and third rows just exchange places, so that looks good. We can sort by a string name, so by this name, or by a string column, so the column name gets sorted from alphabetically. So everything looks good there. So let's go ahead and make this work if ascending is false. So if not ascending, then what we're going to do to order is simply just reverse it. So if we wanted to sort descendingly, we will just reverse it. So this : -1, you should know from just regular Python, this is how you reverse a list. It's also how you can reverse a NumPy array. So if we go here now and say ascending is false, then it'll sort from greatest to least. And we can do this again with like weight. So 100 down to 40. So everything looks good when we're sorting with a single, just a single column. Now we have to implement the case where we have multiple columns. So this is a little bit different. So you say else if by is a list, then we will sort over here multiple columns. So we're assuming by is a list. Now you cannot use argsort to sort multiple columns. NumPy is a separate function called lexsort. So we can give it the columns that we want, and we have to actually give it in the reverse order. So this is a little bit tricky here. So what we're going to do here is we're going to loop through all of the values in the by list. So by is a list. So let's go ahead and loop through here. So we'll say for column in by, and we'll do a list comprehension. So let's go back and do this. And we're going to say we're going to get the data of that like this. So we're going to get a list of NumPy arrays, and we can call this whatever we want. We need to assign this to something, so we can just reassign it to by. That's okay. So we'll just have a list of NumPy arrays. But the way lexsort works is that the array that you want to sort first must come last. So it actually does it like in reverse order. So we're going to give it a list of NumPy arrays with the primary sorting array will come last, which is a little it's certainly not intuitive. So we need to reverse the order of by. So assuming the user will want to use the use the first item in by as the primary sorting column. So let's go ahead and reverse by, and then we will get the underlying data. So for every column in by that is reversed, we will get the underlying NumPy array. So by is now a list of NumPy arrays, and now we'll rely on NumPy to do all the hard work for us, and we will assign this to order. So that should work. And then the very last thing is I say to raise a type error if we don't have a list or a string. So we can say by must be either a list or string. Okay. So, and then we've already implemented it, so we'll just reverse this in the case that we want to go high to low. So, all right, so let's check this out over here in our Jupyter Notebook. So, if we want to sort by multiple values, so let's go ahead and pass in a list here. So if we have a list, well, this should actually still work even if it's a one-item list. So we can try that, and maybe we'll just get rid of ascending. So if we're sorting by weight, that looks good. Yeah, if we do false, okay, now we're going from 100 to 40. Okay, that also looks good. Let's sort by school. So yes, booleans are 1, false is 0. So that's okay. But now, what if we want to sort by multiple columns? So say within school, so within all the true values of school, we will sort by weight. Let's go ahead and do that. So in this case, I've done ascending equals true, so it's going to go from false to true. Now within true, then the sorting will happen from least to greatest. So that looks good. I can make ascending equals false. So within true, so now we're going this way, it'll sort from greatest to least, so from 100 to 40. There's only one false. So that looks good. The only way it makes sense to sort by multiple columns, the only case when it makes sense to sort by multiple columns is when there's duplicate values in one of the columns, or at least in the first sorting column. So in this case, school is the only column that has values that are that repeat. So this is the only way we can actually verify it visually, or else we'd have to add more rows or more columns to our data. But everything is looking good here with at least that simple example. Let's go ahead and test with PyTest. So there's actually 4 separate methods or 4 separate test cases that we're going to test individually. So it's going to be in this test more methods class. And within here we'll test sort values. Okay, so that's that test. That passes that one, so that looks good. We can test the next one, test sort descending. And then let's do the next one, test sort values 2. Okay, good, that passes. And the very last one is test to descending. And great, so we've passed all of the tests. Okay, good. So that does it for sort values and for step number 35.